Hey Ian, how's it going?
Good. How you doing tonight?
Pretty good, pretty good.
Good. You got any tests this week?
Um, no, not this week. Not that I know of.
That's good. How'd the homework go?
It went okay.
Yeah, I didn't think it was too bad. It was
Yeah.
just an extension kind of last week's stuff.
Mhm.
Hey, Jared.
Hey, how's it going?
Good. How you doing tonight?
Pretty good.
Did we get our project approved yet?
I haven't heard back yet.
Okay.
So
I haven't heard anything.
I submitted our stuff um, that Austin put together, and, uh, and then he submitted it on his end. I hope.
Okay, gotcha.
So I guess we're just waiting to hear, and then I guess we collect the data. Is it next week? Sorry, guys. Jared, hi, Austin.
Hey,
How you guys doing tonight?
good. Do I even recognize Jared over here?
Yeah, I was going to say the same thing.
Yeah. Just had a little bit more to go before you look like the other dude.
That's right.
There can only be one.
All right. Does anybody have any questions? Anything we wanted to tackle before we jump into it?
Nope.
This is a pretty simple
Yeah.
thing, I felt like.
Yeah, I was thinking the same thing.
It's almost like a paint by numbers
A little
lesson.
bit. Yeah, you just plug it in. And,
Again,
Here's another calculator you can use.
yeah, indeed. All right. Do you guys want to go over the homework?
Yeah.
Okay. So let's see. What is the null hypothesis for the significance test comparing two population proportions? So the null hypothesis is
it's always the same.
it's P1 equals P2.
Mm-hmm. Okay, what is the formula for a test statistic for testing two population proportions? Explain what each variable stands for. So this is looking for the critical value of the test statistic. They're like the same thing.
The z-score.
Yeah, or is this z-score or is it the test? Oh, test statistic. Yeah, it's all the same.
Yeah.
Z-score. And the difference between this and the single population is just that there's you minus the two, the first population or the first proportion from the second proportion for p hat, and then the proportions as well. And then you do your same with the sample size, if that makes sense. Or you can just plug it into the Excel sheet.
Excellent.
Yeah. What is the confidence interval for comparing two proportions? Explain what each variable stands for. In your formula, it's kind of the same thing Austin was saying, except now we're using a difference. So instead of using the original sample proportion, you're just going to take the difference of them, and plus or minus the margin of error. which is pretty much the same, except now we're looking at another difference. So instead of p hat times 1 minus p hat over n, we're doing it over n plus 2, and then doing that plus the other one, and then square rooting it and finding the critical value.
Why do we do it over n plus 2?
So now p values.
Okay. All right.
I can do 4.
Cool.
There was a recent survey taken on whether consumers are label users who pay attention to label details when buying clothes. Are men and women equally likely to be label users? Determine if the proportion of men who use labels are different than the proportion women who use labels with a level of significance of 0.05. Data summary. Alright. Check the requirements. Let's see.
$296. X1 63.
So the sample size is large enough for both groups, right?
Yeah. You got 63 and 233 in the first sample, 27 and 224 in the second sample.
Yeah, so
So
okay. So it meets the requirements, right?
Yeah.
Okay.
So null. Let's see. State the null and alternative hypothesis. Null hypothesis would be that they're equally likely to be label users, men and women, and the alternative would be that different than proportion.
Yeah. So
If men are different than a proportion of women.
yeah. So P1 is not equal to P2.
Right. Compute the test statistic. Anybody got that? I don't got it.
If you key it into the spreadsheet, it's 3.309.
Okay.
That's the easiest way to do it, is to just do the two proportions part of the spreadsheet.
Mm-hmm.
And I got the p-value of 0.001.
Yeah. Zach, do you have the spreadsheet?
Is it the same one we had last time?
The same one we have that last time. It's just the second tab.
Yeah, I gotta find it again. Hold on.
Okay. Yeah, if you have that, it's easy.
Okay, gotcha.
So E is the shade your p-value on the distribution curve. Since the z-score is 3.309, it's going to be way out on the corners. And it's P1 does not equal P2, so it's two-sided.
Mm-hmm. And since the p-value is super duper small, smaller than the alpha, then we would reckon, meaning that we have sufficient evidence to say that there is a difference in the proportions between men and women.
Cool.
And since all of our numbers are still in the spreadsheet, we can just put in the 95% confidence interval, and we come out with a lower number of 0.045 and a higher of 0.176.
Hey, Zach, were you able to find that spreadsheet?
Yeah, yeah, I got it. Thanks.
You got it. Okay, cool. All right. Do you see where we're getting those values?
Yeah. Let's see. So test statistic, would that be proportion Z test?
That's the z-score.
Okay, gotcha. Yeah.
Oops.
Well, so much for the homework.
Okay.
We jump into the test.
Quiz, yeah.
Yeah. Oh yes. Yeah. Let's not take a test tonight.
Yeah. Group test. I'm not opposed to group testing.
Yeah.
Yeah, I might do a little better.
Okay. Open this up. First ones are true. Okay, I'm guessing we're gonna have to download like 4 or 5 different data sheets.
No, you don't need any data sheets.
Hopefully they'll be right in the answer. That's what they were in the homework.
Yeah, they have the data on the quiz.
Okay. Did you already take the quiz?
Yeah.
Two. Okay. Let P1. Okay, I'll just read the first one. Okay, if questions 3 through 8 refer to the PTC testing study with different data. Out of 70 females in sample, 52 can taste PTC. Out of 59 males in the sample, 42 can taste PTC. Let P1 be the proportion of females in the population who can taste PTC, and P2 be the proportion of males in the population who can taste PTC. The research question for this study is given here. Is the proportion of females who can taste PTC different from the proportion of males who can taste PTC? So find P hat for P hat 1. And if you have the Excel sheet open, P hat 1 equals 0.743.
Yep.
And I'll do 2 since it's right here. The proportion for P hat 2 is 0.712. We all agree?
Yeah.
What were the numbers?
0.743
Uh-huh.
and 0.712.
So you want to do 5?
Sure. Which set of hypothesis is appropriate for addressing the research question? Would be the null would be that they're equal, and then the alternative is that there is a difference, and we're looking at the true proportion, not the sample proportion. So we wouldn't be doing p hat. It would be the true proportion one.
Just
Okay.
regular P.
Yeah, the last one. Well, that's what I have.
All right, so I could do 6. Create a 95% confidence interval for P1 minus P2. And if you have the Excel sheet again, it kind of gives you everything. So the confidence interval would be negative 0.123 and 0.185.
This interval has 0 in the interval.
It does, doesn't it?
So it's invalid, right?
Okay, so 7 is with alpha at 0.05. What decision do you make? Looks like our p-value is 0.693, so we fail to reject the null hypothesis.
Okay.
Is that correct?
Here's
Yeah.
Yeah. Which
Alright, number 8. Which of the following statements best describes the outcome of the study? There is sufficient evidence to suggest that the true population proportion of females who can taste PTC is greater than the true proportion of males who can taste PTC. There is insufficient evidence to suggest that the true proportion of females who can taste PTC is different. There's insufficient evidence to suggest that the true proportion of females who can taste PTC is less than the true proportion of males.
I think I'm good with the second one.
Yeah, that's what I was thinking.
This is the same data right out of the homework, or out of the chapter.
So you're saying we could just pull up the chapter page and get the answers?
Well, I don't know if the numbers are the same, but it's the same.
Oh yeah, the heart attack stuff.
Yeah.
6713.
6713. And
I'll read you the numbers if you want.
okay.
Okay, and the other data N is, for N2, it's 42447. And for P2, it's 6155.
Okay.
Okay. Are these, yes, they're satisfied.
And in this one, they're asking if the heart attacks are less often, may not lead to death on weekends rather than weekdays.
So we want P1 is less than P2?
Yes.
Yeah, because they'd be less
First
during the
one.
weekday. Yeah. All right, so we met the conditions, right?
Yep.
And we have the first option on question 10.
Yeah.
Okay.
And then it's in the same order if you just type it in order. P1 is going to be your heart attacks in weekdays, and then P2 is going to be heart attacks on weekends. So
Okay.
you have 1 will be 0.14, and then 2 will be 0.145.
Okay. All right. I have a z-score of negative 2.020.
Yeah.
Now you want to shade to the left.
Yep.
That should give you a p-value of 0.022.
Yep.
Yep.
So you reject the null, and there is sufficient evidence to conclude that the proportion of patients who have a heart attack and are admitted to the hospital on a weekday who die is less than the proportion of patients who have a heart attack and are admitted to the hospital on a weekend who die.
And that's the first choice.
Yep.
Okay.
Awesome.
That's different from the test or from the chapter. So they had different numbers. Okay, so we're doing number 1, right? There was sufficient evidence to conclude the proportion of patients who had a heart attack is less than the proportion who had, yep. Okay. We want to fire away?
Yep, it's right.
All right, groovy.
Good job, guys.
That was quick and painless.
That was.
Till next time.
Absolutely. All right.
Tuesday.
Hey,
All right, see ya.
Austin, have you heard anything from your instructor on the approval thing? We haven't
For the
heard, we haven't
group
heard from any on our group stuff either.
No, I haven't gotten anything. Yeah, let me look at my email. I've been checking my email and haven't gotten anything yet. But I
Okay.
sent you my thing, right? You got that?
Yeah, I did, and I made a couple of changes and I sent it back. Did you get
Okay.
that?
I just saw that you looked at it. I didn't really see.
I
I submitted a copy of it. Either
Okay.
way.
All right. Sounds good.
And after thinking about it, I think there was one thing that looked like it was that could have been changed. I don't know if it would make a difference.
Yeah, the thing that I changed was the null hypothesis. It was on the ANOVA. It's
Yeah.
the null is all means are equal or one of the means
There's
is
one
different.
there's something that's off.
Yeah.
Yeah, I haven't got anything back from the teacher about.
Okay. Neither have we. I'll let you know if we do.
Okay.
All right. Thanks. Have a good night.
I'll see you guys.